The first thing you will always want to do, if possible, when factoring, is to factor out the greatest common factor. In the case of 18x to the fourth minus 30x squared, if we first think of 18 and 30, the largest number that is a factor of both of those terms is 6. Next, thinking of x to the fourth and x squared, because there's a variable in every term, we need to factor out a variable. And to figure out what power of the variable to factor out, you factor out the smallest power of a variable that's in every term. So in this case, for x to the fourth and x squared, we'll factor out an x squared. Since we're factoring out a 6x squared, if we want to see what's left, we can think of taking our original terms and dividing them both by 6x squared to see what would remain when we factor out the 6x squared. 18x to the fourth divided by 6x squared, we would be left with 3x squared. And then minus 30x squared, when we factor out 6x squared, the x squared and x squared would be factored out completely. There's not going to be a variable remaining. Negative 30 divided by 6, we have minus 5. So 6x squared times 3x squared minus 5 is our answer. Looking at our next problem, we have negative 4x squared plus 4x plus 48. When you're factoring out a greatest common factor, in a lot of situations that we're going to run into with different sorts of rational functions or so on, it's going to help when you have a negative number as a leading coefficient. It's going to help when you're factoring something out to factor out a negative greatest common factor. So let's do that here. We can see that 4, 4, and 48 are all divisible by 4. And since our expression starts with a negative, we'll factor out a negative 4. Now we can't factor out a variable here because that last term doesn't have a variable. So to see what remains when we factor out a negative 4, we divide all of our terms by negative 4. Negative 4x squared divided by negative 4 is x squared. 4x divided by negative 4, we have a minus 1x. 48 divided by negative 4, we have minus 12. I'm going to look at that middle term and think of it as a minus 1x, because here we're actually not done factoring yet. The reason is the parentheses that we're left with, x squared minus 1x minus 12, we can factor and break apart into two binomials. Notice the negative 4 doesn't go away. The greatest common factor that we factored out stays out at the front. Now this next parentheses, we split it up into two binomials, each of which starts with an x. To multiply to be negative 12 and add up to a negative 1, we can use a minus 4 and a plus 3. If you'd like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. To factor 3x to the third plus 21x squared plus 36x, first we need to factor out the greatest common factor. For 3, 21, and 36, the greatest common factor of those numbers is 3. Since all of our terms do have the variable x, we'll need to factor out an x. And thinking of our exponents, we have x to the third, x squared, and x to the first. We'll factor out x to the first, or in other words, we're going to factor out 3x. To see what remains when we factor out 3x, we can think of dividing all of our original terms by 3x. 3x to the third divided by 3x, we'd be left with x squared, plus 21x squared divided by 3x, we'd be left with 7x, plus 36x divided by 3, we're left with 12. In this case, we are able to factor that parentheses. The 3x that we factored out as our greatest common factor stays at the front. We'll turn this remaining parentheses into two binomials, each of which starts with x. To multiply to be 12 and add up to 7, we can have plus 3 and plus 4.